Lizzie is a soil scientist at Teagasc with specialist knowledge on of soil and nutrient management and diffuse pollution of air and water from agricultural systems. Her current R&D projects focus on precision farming, improved nutrient management, and the environmentally sustainable recycling of organic materials to land. Lizzie led the review of evidence on the principles of crop nutrient management for horticultural crops, and that would have informed the nutrient management guide they call RB209, which is like our green book, which I know many of you will be familiar with. And she currently leads the multi-partner EU Interreg project, increasing the speed and uptake of innovation in field vegetable and potato sectors. And that's defining a new approach for delivering cost-effective research called InnoVeg. And I think she will allude to that later on in her presentation. So thanks, Lizzie. And I'd like you, if you don't mind, share your screen, and we look forward to your presentation.
Perfect. Thanks, Andy. So I also just wanted to say, Andy, Eoin, as I go through, I won't be monitoring the chat. So if there are any questions that pop up that are particularly relevant, please do feel free to jump in. So good evening, everyone. It's great to be with you here tonight for this talk. Andy asked us to talk on nutrient management for field vegetables. We've only got an hour, and given current sort of increases in fertiliser prices, we're going to focus on improving nutrient use efficiency. And yeah, it was interesting to see, I'll pick up on it in a minute, the number of you that said that you had thought about reducing your fertiliser nitrogen use in response to the increase in fertiliser prices. So I mean, this is all very topical at the moment. Hiking energy prices is having a major knock-on effect on fertiliser supplies, and I think this has really focused attention on our fertiliser inputs. So you can see the graph on the screen. I've just got, I'll get my laser pointer up here. Shows the fertiliser price in pence per kilogram of nutrient between 2007 and today. So you can see phosphate prices are in orange and potash in green, and you can see that P&K prices are now approaching similar prices to the last peak that we saw in about 2008. Nitrogen prices are shown in blue by the blue line, and you can see that these have really rocketed and now significantly above the previous 2008 price high. I'd noted down, I thought urea was about 860 euros per tonne, but I think the guys mentioned a minute ago sort of closer to maybe 1,000 euros per tonne. Muriate of potash at 630 euros a tonne, and triple super at 620 euros a tonne. So increasing our fertiliser use efficiency and producing more crop with less fertiliser inputs is also one of the key ways we can reduce the environmental footprint of agriculture and step towards net zero. So obviously fertiliser prices are focusing our attention, but it's, improving fertiliser use efficiency. It's good for farm profitability, it's good for reducing carbon footprint and minimising environmental emissions. There is a carbon footprint associated with all fertiliser products, and it is greatest with nitrogen due to the high energy cost of production. Therefore, anything we can do to improve our nitrogen use efficiency is kind of a key driver of improving the farm's carbon footprint. And also just it's important to remember the nitrogen fertiliser application can also be a source of diffuse environmental pollution. Potentially can be lost via nitrate leaching, ammonia, volatilisation or nitrous oxide. And clearly what we want is any nitrogen we put onto the crop, we want to get it in the crop and we don't want to lose it to the environment. Having said all this, we mustn't forget that nitrogen fertiliser often gives us the greatest yield response of any input. So the focus here is really on increasing nitrogen use efficiency and applying the economic optimum amount of fertiliser. So let's start at the beginning. How do we decide what nitrogen rate to apply to the crop on your farm? So we need to start with a recommendation system, and in Ireland you've got the Green Book recommendations, which we've already mentioned are broadly in line, I think broadly in line with the recommendations that we have in the RB209 document we have in England. The nitrogen recommendations in the Green Book are based on a soil nitrogen index. You can estimate this index based on past cropping and a soil type, or you can measure it. by taking samples for analysis. And we'll talk a bit more about this on the next slide, as this is one of the ways that, that I think we're definitely using more over in England. It can help improve our nitrogen use efficiency. If you are applying organic materials, you need to calculate the nutrient supply from those materials. Organic materials contain plant nutrients and can save you money on your fertiliser costs, but you need to know how much you're applying and how much will become available to the crop. Again, the best way to do this is to take a sample and get it analysed, and we'll touch on that again later as well. So I said here, make just strategic decisions on fertiliser use. So, I mean, the Green Book is your recommendation system. This is your starting point, but do use your experience to judge and learn from past successes and failures, from basic things like correcting any fertiliser misses or overlaps in future crops, to more nuanced decisions informed by past crop yields and quality. For example, we know that high N rates can increase the risk of pest or disease pressure, for example, head rot and broccoli. And this may be, so some of these things may be an indicator that the N rates are a bit too high. So it's important to look at your crop and use your experience to judge your fertiliser use. I would say that if you wanted to check or validate your nitrogen rates, the best thing you could do is the test on your farm. Things like apply a bit more or a bit less nitrogen to alternative tramlines across the field to enable you to assess the impact on your own farm. And definitely this is something that I would encourage you to do, if you wanted to check your nitrogen rates. So nitrogen recommendations are given in the Green Book are based, I've said already, on the economic optimum N rate. This is the break-even price point at which the value of the extra yield is cancelled out by the cost of the extra nitrogen applied. It was particularly interesting, the response to the poll when we asked how many of you had thought about reducing your nitrogen input costs, your inputs, because of the increase in fertiliser price. I think I noted down 73% said they'd thought about that. I might, because actually that's not my recommendation I'm going to give you here. Because of the high value of vegetable crops, the economic optimum N rate has always been considered to be fairly close to the nitrogen rate required to give us maximum yield. However, obviously the massive increase in fertiliser prices has, as we've seen from the response to the poll, caused people to question whether or not they should cut that nitrogen use. And you may have seen guidance in the farming press, certainly over here in England. We are recommending growers cut back on nitrogen applications to cereals and oilseed rape. So I think we're recommending cutting back by about 50 kilograms per hectare of nitrogen to cereals, about 70 to rape. Well, what about for veg crops? Well, I thought to help us answer that, it's useful to look at the cost of nitrogen fertiliser as a proportion of the value of the crop. So I've put here, there's a few places in my presentation where I've referenced ammonium nitrate, nitrogen fertiliser. I would say, I know most of you would use calcium ammonium nitrate or urea, but I think the price of them in terms of nitrogen is fairly similar, so that the principles are the same. So the example I've got here, with ammonium nitrate, about 750 euros per tonne, a 200 kilogram of nitrogen per hectare application cost us 435 euros per hectare. So if we look at a cereal crop, that is 25% of the value of a wheat crop, with wheat at 230 euros per tonne and yielding 7 tonnes per hectare. But if we look at it at a proportion of the value of a couple of veg crops, it's about only 3% of the value of a broccoli crop, with broccoli at 970 euros per tonne, yielding 15 tonnes per hectare, and less than 2% the value of a leek crop, of leeks at over 1,000 euros per tonne and yielding 25 tonnes per hectare. Now these figures may be slightly different in Ireland, but hopefully you can get the picture and the point that I'm trying to get across here. Because the cost of nitrogen is a relatively small component of the crop value for most field vegetable crops, the economic optimum N rate is fairly resistant to the changes in the price of nitrogen. And I certainly wouldn't be recommending that you cut back your nitrogen rate because of that. And we can illustrate that here. But what I've just done is I've got a case study example here where we've kind of scenario tested it. This is some nitrogen response data from a 2021 broccoli crop. It's work that my colleague Angela Huckle did with AHDE last season. The graph we've got here shows the increase in the crop value. So it's crop value in pounds per hectare minus the fertiliser cost against the increasing nitrogen rate. So the graph is based on a nitrogen price of £500 per tonne, so about €590 per tonne. And at this price, the economic optimum is 182 kilograms per hectare. And what we did is we tested the impact of increasing end prices to £700 and £1,000 per tonne, so on optimum end rates. So increasing to £700 per tonne, which is about the current fertiliser price mark, was about 826 euros per tonne. Increases our optimum end rate to 178 kilograms per hectare, increasing to £1,000 per tonne, just over 1,180 euros per tonne. Decreases our optimum end rate to 176 kilograms per hectare. So what this illustrates is that, that this point I'm making, that substantial increase in the cost of fertiliser and nitrogen, it really had very little impact on the optimum end rate. What we're looking at, and it's a similar picture in other crops where we scenario tested, you're really looking at sort of plus or minus 5 to 10 kilograms per hectare. And to be honest, I really don't think that's enough to try and make a change to end rates. Most of us would probably be doing well if we could confidently spread with an accuracy of plus or minus 5 kilograms per hectare. So not advocating you reduce your end rates because of the increase in fertiliser end prices, but we are recommending that now more than ever, it's important to get your nitrogen use right and take steps to try and maximise your nitrogen use efficiency. So let's have a look at what should you be doing? What would we be recommending that you do? So I think it's important to state the obvious, start by getting the basics right. I'm sure these first bullet points that we've got here are all things that you know, but it is worth restating, as getting these right will have the biggest impact. So make sure you're at optimum pH. I think your target for tillage crops is 6.5. I'm sure many of you are familiar with this image that we've got here, showing how nutrient availability varies with soil pH. At the target pH of 6.5, the availability of most nutrients is optimised. If you're below the target soil pH, nutrient availability will be reduced, and this can have a knock-on impact on crop yield. So getting pH right is really important. Similarly, make sure you have sufficient supply of phosphate, potash, magnesium, sulfur. Liebig's law of the minimum states that if a plant's growth will be limited by the nutrient in shorter supply, so your nitrogen use efficiency will be reduced if you are deficient in one of these other nutrients. We want to ensure you've got good soil structure that can support good root growth and enabling those roots to take up the nutrients that you've got in the soil. If you are using organic manures, and I think was about half of you said you would consider substituting some of your mineral fertiliser for organic manures, make sure you allow for the nutrients contained in the manures and take steps where possible to minimise any nitrogen losses in order to maximise the amount of nitrogen we can get into the crop. And then to assess soil nitrogen supply. So those are the basics. Work on those first, get these right first. Once you've done this, what we've listed here is, what else, at the moment, people are asking, what else can we do to try and drive, if we've got all these basics right, what next can we do to try and drive improvements to our nitrogen use efficiency? So you could consider measuring soil mineral nitrogen. So we said you need to assess soil nitrogen supply. If you want to do better, you could consider taking a sample and getting it analysed. This is potentially a more accurate way to assess the soil nitrogen index. Also, I'm focusing on nitrogen, but we'll pick up on some of the other nutrients as well. In low P index soils, you could consider placing phosphate fertiliser. Other things that you could consider to try and increase nitrogen use efficiency, where I think, or just general nutrient use efficiency, where I think there is a logic as to why it may help, but where the evidence of benefit is more limited, include things like fertiliser nitrogen efficiency products or enhanced efficiency fertilisers, variable rate application of fertiliser, and better matching of fertiliser application timing to crop growth. So now we'll go through some of these in a bit more detail. And I want to start by, first of all, picking up on a couple of slides on organic manures. So it was interesting. I wasn't sure how many of you be using manures. Sometimes there's concern about using them in fresh produce because of the potential risk of pathogen contamination. So I would say, you know, if you are growing veg crops and you're thinking about applying manures, the first thing to do would be to check your bio requirements and that you are able to actually do that. But I would certainly say that there has been increased interest in the value of muck recently due to the increase in fertiliser prices. It's certainly something that we've been asked quite a bit more over the last couple of months. So to start off with, I wanted to jump in there with a very important question of what's it worth? You know, if any of you have got muck, you're probably interested in a moment about what's its value. You know, I think, you know, I hope that we all know manures are a valuable resource. They contain nutrients that can be used to replace the need for bag fertiliser, and these nutrients have a value, and we can work out this value by looking at how much it would cost to buy those nutrients in bag fertiliser. And given the large increase in fertiliser costs, manure today is worth quite a bit more in terms of, you know, euros of nutrient value than last year. So what we've got here, this is an example of cattle farmyard manure applied at 40 tonnes per hectare. So a 40 tonne per hectare application of cattle manure applied in surface broadcast in the spring would typically apply about 24 kilograms per hectare of crop available N, 128 kilograms per hectare total phosphate, and 376 of total potash. And so what we've done here is we've worked out the value of those nutrients in euros per tonne and euros per hectare based on prices back in spring 2020, which we've got the assumed prices here, and based on current fertiliser prices, which we've got there. Again, I'm referencing ammonium nitrate, but I've checked with the guys and think we're fairly similar with calcium ammonium nitrate there. So the key thing here, so back in spring 2020, this cattle manure application was worth about €7.75 per tonne, and 40 tonnes per hectare was worth about €310 per hectare. Now, with the increase in fertiliser prices, this is worth over €15 per tonne, and this application could be worth over €600 per hectare to you. So quite, you know, re-emphasising the point that, that it's a valuable resource for your farm. Just one more example. So it started off with cattle muck. I wanted to include a slurry as well here. We've got a pig slurry applied at 50 cubes per hectare. Again, spring surface applied. This pig slurry application typically will apply just under 100 kilograms per hectare of crop available N, 75 of total phosphate, and 110 of total potash. And last year, back in spring 2020, this slurry was worth just under €4 per cubic metre, and this application of 50 cubes per hectare would be worth just under €200 per hectare. Fast forward today, and you know, the price has doubled, so we're now looking at €8.50 per cubic metre, and this application being worth about €425 per hectare. So definitely worth having, because of the, you know, and because of the value of that those manure nutrients. It is worth you taking steps to make sure that you maximise the value of those nutrients to you. So whenever we're doing what I'd call a making the most of manures presentation to farmers, these are the things that we say you should be doing in order to make the most of those manure nutrients. So first of all, make sure you have reliable information on the manure nutrient content, how much nitrogen, phosphate and potash is actually in the manure on your farm. Now, I know in England we publish standard or average figures. I'm sure you've got similar in the Green Book. But I would say that those sort of averages, they are only averages. They conceal quite a bit of variability. So I would recommend taking samples and getting them analysed by a lab. That will give you the most accurate information about what's in that manure. Secondly, once you know what's in it, you need to estimate how much those nutrients will become available to your crop. Thirdly, where possible, take steps to minimise nitrogen losses. So things like, ideally don't apply in the autumn winter because you'll lose nitrogen via leaching. And ideally try and take steps to reduce ammonia losses, either by incorporating or using band spread or shallow injection applicators. Then when you come to spread it, make sure you spread it accurately and evenly. We would say to farmers, you should really be taking the same sort of care over your manure applications as you do with your bagged fertiliser. And then finally, when you come to spread the manure, you need to build it into your farm nutrient plan. So once you've worked out how much nitrogen, phosphate, potash the manure has supplied, you need to make sure you reduce your bagged fertiliser use accordingly, because if you don't reduce your bagged fertiliser use accordingly, you actually haven't saved yourself any money there. Mark, I don't know whether you want to comment at all on use of manure, so something we were talking about earlier.
Yeah, I think you've covered it quite well there, Lizzie. I think it's very, very important to get it tested to know what's in it. Very important to spread it evenly, and definitely a spring application. If you're going the autumn with some organic manures, we'd strongly encourage that you have a cover crop or something in there to mop up, especially the nitrogen part. And I suppose the thing that we haven't mentioned, Lizzie, is that we were adding a lot of soil organic matter, a lot of carbon to the soils as well, which would bring big benefit, especially to where there's a lot of edge crops in the rotation from a soil structure point of view. So look, I think if you can get organic manures, there's major benefits, and especially in the current year, as you say, it's very, very important to make the adjustment to what's in them. And I suppose possibly apply a lower application rate, maybe cover a bigger area as well. You know what I mean? Maybe supply 20-30% of the crop's nutrient requirement through the organic manure. You know what I mean, and then supply the balance with bag fertiliser. But look, there's big benefits there, Lizzie. Absolutely.
Could I just throw in a question, Lizzie and Mark, while we're on that topic? I mean, we are getting a lot of people asking about whether it's slurries or farmyard manure, or even spin mushroom compost. Are we happy to say that we have no issues? You mentioned about the biological issue, but aside from that, are slurries and other manures suitable on the full range of vegetables and potatoes, or would you caution against the use of slurries on particular crops?
I suppose the one that comes to mind, Andy, is the broiler manure. Like, there is an issue there with botulism. So again, I would be taking care and maybe put it into maybe on a different crop. And the rules have changed. The department brought out new rules on the management of especially a broiler manure or broiler litter. Like, it has to be ploughed in as soon as possible. So I'd encourage anyone on the call that's using broiler manure to check with the new regulations. That's the one that springs to mind that I suppose of most concern, Andy.
So slurries on the likes of carrots, root crops, you'd be quite happy pre-sowing, incorporating in slurry before?
I don't think that, Lizzie, I don't think there's any big issue with the likes of your cattle slurries or your farmyard manures or your pig slurries. Now, I stand to be corrected, but
yeah, I mean, the only comment I would have there is check what the nutrient supply from the material is against for that crop. Is something like, like a slurry before carrots. Slurry is quite high readily available, and carrots don't really have a massive nitrogen requirement. So I mean, this is try and match the nutrient content of the material to a crop that needs those nutrients. And if you have another crop in the rotation that more closely matches the nutrient content of the manure, can feel where you get the most value, which crop you get the most value from those manure nutrients.
Okay, fair point. Okay, thanks.
Thank you. Okay, so just want to move on now to talk a bit about assessing soil nitrogen supply and potential for soil mineral nitrogen testing. So we talked about referencing your Green Book recommendations. So if you're looking to get a nitrogen recommendation for your crop, the first step is to work out soil nitrogen supply. So in England, we call this the SNS, soil nitrogen supply. In the Green Books, I think it's referred to as your nitrogen index. This is a measure of the soil nitrogen that will be available for crop uptake during its growing season. It includes soil mineral nitrogen plus any nitrogen mineralization during the growing season. This soil nitrogen supply directly reduces our need for fertiliser nitrogen, so it's important to understand it and to be able to assess it. And it can vary quite substantially. We can see it varying quite substantially between fields. The main factors affecting soil nitrogen supply are soil type, so high organic matter soils, heavier textured clay soils hold and mineralise more nitrogen than lower organic matter, light textured soils. Previous cropping has an impact, so crops that leave a lot of high nitrogen crop residues like leafy brassicas tend to increase SMN for the following crop. Overwinter rainfall, high rainfall areas tend to have lower SNS in the spring due to higher overwinter leaching losses. Fields of history of manure use tend to have higher SMN, and also take into account previous crop performance. So for example, if the previous crop yielded less than expected, then SNS might be increased as the crop might not have taken up all that fertiliser that was applied for it. So at a minimum, you need to follow the guidance in the Green Book to take account of past cropping and soil type to estimate your nitrogen index. And using this approach will give you a pretty good estimate of the nitrogen index. However, soil mineral nitrogen sampling will give us a more accurate measure of soil nitrogen supply, and it can help us improve the accuracy of our nitrogen fertiliser applications. And it is certainly something that we're seeing more growers do over here in England. But there is a cost to SMN sampling and analysis. Over here, lab costs are about £14 per sample. I think it's about 16-17 euros per sample. For most crops, we recommend sampling 3 depths, so 0 to 30, 30 to 60, and 60 to 90 centimetres. So you're looking at about €50 for lab analysis of soil from 3 depths. Plus, obviously, you have the sampling costs. Because of this, we tend to recommend targeting sampling SMN to fields where SMN levels are likely to be high or uncertain. So for example, fields with a history of organic manure use or following high nitrogen residue crops, because this is where you're likely to get the most value from SMN sampling. If you are going to sample, particularly before veg, make sure you take the samples as close to planting date as possible. And this is particularly important for spring or summer plant veg crops, where we will get some mineralisation as soils warm up before planting. Sample to 90 centimetre depth and 30 centimetre sections, or to rooting depth for shallow rooted crops. So for some veg crops, you might knock back to 60 or 30 centimetres. I would also say that if you are going to go to the cost and effort of sampling, it's really important that you handle the samples carefully. The key thing is chilling them as soon as possible after sampling and getting them to the lab as quickly as possible for analysis. The final comment I want to make on this slide was, some of the UK laboratories are now offering what we call AAN, or additionally available nitrogen analysis, as well as SMN. So AAN provides an estimate of the amount of nitrogen that will become available to the crop from mineralisation during the season. And there is evidence that analysis for SMN and AAN together can improve the estimate of soil nitrogen supply and improve our nitrogen fertiliser use efficiency. Now, I do want to quickly jump back. I did say to Mark I might pull him in at this point, because I know my comments have been based on what growers have been doing over here in England, and I didn't know whether, Mark, you wanted to comment on sort of availability of SMN testing in Ireland.
Yeah. Currently, we don't have a soil mineral N test. There has been work done on different tests and their suitability for Irish conditions, and there is a test that is suitable, but it's not commercially available. But it would be great, Lizzie, if we could get a handle on how much nitrogen is available in the spring to the new crop or to the current crop. Like, we have done a little bit of work there on some cover crops on the tillage side of the house, and we have found anywhere between 10 and 70 kilograms of N uptake by cover crops, and even some oilseed rape crops up to 200 kilos. So there can be a lot of nitrogen kicking around. especially this year, because we've had a very dry autumn. Like, we've had little rain in the back end of the year. So, you know, if it stays a reasonably dry year for the next number of months, you'd imagine that there should be, you know, a reasonable amount of, I suppose, available nitrogen there in soil. So it would be good to get some handle on that. And as you rightly point out, I suppose it's the fields or the parts of the rotation where maybe you've come out of grass, or where you've used a lot of organic manures in the past. I suppose it would be good to get some estimate as regards how much nitrogen is available, because in the current year, like, I know to say that we're not adjusting the rates on veg crops, but like, you know,
I would say definitely one to consider in the future, because I think it does have potential to improve your nitrogen use efficiency. Yeah,
absolutely, yeah.
So are UK growers adopting this kind of testing or analysis in a big way, or who's doing it, Lizzie?
Definitely. So I think there's a couple of labs in the UK that are doing this quite a bit at the moment, and we've definitely seen an increase in the popularity of the tests. So I mean, I couldn't give you proportion of growers, but you know, I know the labs are very busy, and it's something we talk to farmers regularly about, and I do think that you know, it is starting to be more used.
Okay, thanks. Could I just remind our audience to you know, if they have any questions on their minds, even at this stage, while they're listening to the presentation, you know, just pop it in that question and answer tab, and we'll deal with it in the discussion after Lizzie's presentation. Okay, thanks, Lizzie.
Thanks, Andy. Okay, so now I want to move on and consider sort of other strategies that we could think about using to improve our nutrient use efficiency. So under this banner of precision nutrition, I want to cover sort of enhanced efficiency fertiliser products, variable rates fertiliser application, both of phosphate, potash, lime and nitrogen fertiliser, placement of phosphate fertiliser, and strategies to better match fertiliser application timing to crop growth, and on-farm testing as well. So we'll step through some of these. So first of all, enhanced efficiency fertilisers. There are a range of these fertiliser products now available, claiming to improve our nitrogen efficiency. So what I've done in this table here, it's important to distinguish between modes of action between the different products. So this table has grouped different types of nitrogen efficiency products by mode of action. So firstly, we have our urease inhibitors. So these delay the hydrolysis of urea to ammonium, thereby reducing the localized increase in soil pH and ammonium concentration. And it's that peak in ammonia concentration and an increase in pH that tends to drive ammonia volatilization. So urease inhibitors help us reduce that. And ammonia loss from urea-based fertilizer can be quite high. And I would say definitely urease inhibitors can reduce this ammonia loss and can therefore increase nitrogen efficiency of these products. So if using unamended urea, I would recommend using a urease inhibitor to reduce your ammonia losses and increase efficiency. Next in the table, we've got nitrification inhibitors. So these slow the conversion of ammonium to nitrate, and by delaying the oxidation of the ammonium to nitrate, nitrification inhibitors can reduce the proportion, can reduce the nitrous oxide emissions. We are seeing some products that combine both nitrification and urease inhibitors. And finally, I've also got here slow or controlled release fertilizers, where we are aiming to sort of slow or control the release of the nutrient over time through use of a physical or chemical barrier. And the idea then is the timing of that nutrient release more closely matches our crop demand for that nutrient. So I've just got a couple of slides of data from trial work on a couple of these different types of products. This graph here is from the DEFRA-funded NT26 program work that measured ammonia emissions for different fertilizer products. This graph shows the average ammonia emissions, and we've got ammonia loss as the percentage of nitrogen applied. It's an average emission from five fertilizer nitrogen products applied to winter cereal crop over 10 sites. So ammonia emissions were a mean of 24% from the urea, 14% from the UAN, and 3% from ammonium nitrate. Using a urease inhibitor reduced ammonia emissions from 24 to 6% for urea and from 14 to 8% for our UAN. And ammonia emissions from the solid urea with an inhibitor were not statistically different from emissions from ammonia nitrate fertiliser. So, you know, and you can see the sort of a, you know, to be losing a quarter of the nitrogen you put on as ammonia, I mean, it's not good for you because you're losing fertiliser nitrogen. It's not good for the environment. So use of urease inhibitor will reduce these ammonia emissions and therefore will help you increase your nitrogen use efficiency. So, you know, win-win there. Another sort of bit of data from some trial work we've done. This graph here is from some work we did looking at nitrification inhibitors. So I mentioned already, nitrification inhibitors look to slow the conversion of ammonium to nitrate. By delaying this oxidation, the anions can reduce the amount of N2O, nitrous oxide emissions. Now, the thing with nitrous oxide, emissions of nitrous oxide are primarily driven by soil and weather conditions, and they tend to be higher in warm, wet conditions. In this study, we measured nitrous oxide from ammonium nitrate and urea with and without a nitrification inhibitor at two sites, our Gleethorpe and Boxworth sites. You can see here that emissions are quite a bit higher from our Boxworth site compared to our Gleethorpe site across the board, and this will reflect soil and weather differences between the sites. But you can also see that emissions were lower where we used a nitrification inhibitor, and on average across this trial, I think we had a 44% reduction in nitrous oxide emissions. So this is obviously clearly positive from an environmental perspective because nitrous oxide is a greenhouse gas, but agronomically, nitrogen losses via nitrous oxide are small. So if you just sort of compare the scales, the previous scale where we were looking at urea losses, we were losing up to a quarter of the nitrogen applied as ammonia. Here, nitrous oxide emissions tend to be, you know, a kilogram or so per hectare. So, you know, reducing nitrous oxide is great for the environment, but agronomically speaking, it's unlikely to have much of an impact on your nitrogen use efficiency. Okay, so now I wanted to move on and talk a bit about variable rate fertiliser application. We know that soils can be very variable. I'm sure many of you have fields on your farm where soil type varies quite significantly. And if you have significant within field variability in soil type, you may also expect to see some sort of variability in soil pH or P&K indices. And if this is the case, there may be a rationale there for variable rate application of fertiliser and lime. If this is something that you want to consider, if you want to go down the route of variable rate PK or lime, you need to carry out detailed soil sampling in order to be able to map soil nutrient availability or soil pH, because you need those maps of variability in order to produce your variable rate prescription map. The different agronomy and precision farming companies have different approaches to soil sampling and for nutrient mapping. You know, some sample on a grid basis, you know, where you regular, you know, one sample per hectare on a regular grid. Others may sample on a zone basis, where, for example, maybe they do an EC scan and they use the EC scan as a basis for creating zones, you know, of similar soil type and sample within those zones. These maps that you've got here our soil nutrient maps are from a 10 hectare field, and for the purpose of soil nutrient mapping here, the field was divided into approximately 1 hectare polygons, and one soil sample was taken from each polygon, and that the results from that soil analysis was then assigned to the whole 1 hectare area. And these sorts of maps can then be converted to what we'd call a prescription map, or for variable rate fertiliser or lime application. Whether or not you take the soil samples on a grid or a zone basis, I mean, obviously the key factor to the accuracy of the map is the number of samples you take. And generally, most precision farming companies, particularly certainly in England, are looking at taking about 1 soil sample per hectare for producing these sorts of maps. Clearly, the more samples you take, you're more accurate in your map, but there is a balance because obviously more samples costs more. So potential advantages of variable rate phosphate and potash or lime include potentially savings in fertiliser costs from not over applying in higher index areas, but probably more important is the potential for increased yields if you have lower index areas of a field that would otherwise have been under fertilised. And I definitely see that as the main benefit of this sort of more intense soil sampling, the potential to show up areas which may be lower pH or lower index where you may get a yield response, and then you can deal with that. Variable rate nitrogen works a bit differently. Here we can see, here we use a crop canopy sensor to help us make decisions on the nitrogen rate. Canopy sensing, you're measuring light reflectance from the crop canopy. Crop canopies absorb some of the incoming light and reflect some of the incoming light, and we can use information on crop reflectance as an indicator of crop growth and performance. There are a range of different platforms and methods for collecting crop canopy information, including satellites, tractor-mounted sensors, and drones. The principle behind it is it's a crop with a, if you've got a crop with a thick, well-developed canopy, that's likely to have a different nitrogen requirement to a crop with a less well-developed canopy. And we can use information on crop canopy variation across a field to vary the nitrogen rate by basically applying more nitrogen to thinner areas of the crop and less to thicker areas. Tractor-mounted sensors such as the RN sensor or the Isaria sensor can be used to vary N rate on the go. If you're using satellite or drones, the imagery can be used to provide a prescription map for variable rate nitrogen. But there are a couple of things to consider with variable rate nitrogen applications. The first is we are assuming that any variation in crop biomass or nitrogen uptake that we measure is due to soil nitrogen supply. Now, this might be the case. We know that nitrogen is one of the key factors affecting yield. However, variation in crop canopy across a field is not necessarily always due to nitrogen. It may be due to a number of other factors. You also need to think about how much you vary the nitrogen rate by, if you're using variable rate N for broadacre arable crops, you may well get good guidance from your precision farming or agronomy company on how much to vary the nitrogen rate by. If you're using it in veg crops, you're likely to be on your own. It'll be up to you and your judgment to decide how much you want to vary that nitrogen rate by. So I just wanted to sort of illustrate that with a case study. Back in 2016, we did some work with AHDE to look at sort of demonstrating the use of variable rate application of nitrogen to a Savoy cabbage crop. The aim of this work was to try and demonstrate the potential for variable rate N. What we did is we set up an experiment to answer a number of specific questions. So firstly, we wanted to know if the optimum N rate varies across the field, because variable rate nitrogen applications will only benefit the crop if we have some level of variation in crop fertiliser N requirement across the field. Secondly, we wanted to know whether we can relate crop canopy information to crop biomass or nitrogen uptake during the season. And thirdly, we want to know, does it work? Can we measure a yield response to varying the nitrogen rate? In order to try and address these things, we did two things at this demonstration site. So we set up nitrogen response experiments in different areas of the field to see if the optimum N rate varies across the field. And we also took regular crop canopy measurements from these N plots during the season and took biomass samples to see if we could relate crop sensing data to crop biomass. And we also set up tramline comparisons, so comparing flat rate compared to variable rate nitrogen to see whether we could see an effect on yield. So here we have some of the results. So this graph here shows NDVI. This is what we call a vegetation index. It's basically a measure we get from the crop canopy sensor, plotted against biomass for 3 different sampling dates between 3rd of August and 15th of September. So what you can see is the crop canopy measurements from the N response plot showed a strong relationship between NDVI and total biomass, and between NDVI and also crop N uptake. So this tells us that crop canopy sensing can be used to provide a good proxy measure of variation in the Savoy cabbage biomass and nitrogen uptake during the growing season. This graph here shows marketable yield response to applied nitrogen. So you can see we had a large yield response to nitrogen, increasing from about 10 tonnes per hectare for the 0N treatment up to a maximum of 44 tonnes per hectare at the highest N rate. So the crop's very responsive to nitrogen, and we can relate crop canopy information to crop nitrogen uptake. So the basis for variable rate management is there, and if optimum N rate did vary across the field, then it's reasonable to deduce that we might be able to have seen a benefit from variable rate nitrogen. But at this site, we didn't see any evidence that the optimum N rate varied across the field. We had 3 separate N response experiments across the length of the field. We fitted N response curves to each of those 3 experiments, and statistically, there was no difference in the N response between the 3 experiments. So if your optimum N rate, your crop requirement for fertiliser nitrogen doesn't vary across the field, then variable rate nitrogen isn't going to be a benefit to you. And we saw this as well, because we tried this out. We had these tramline comparisons comparing uniform nitrogen rate with variable rate N. So nitrogen was applied in 3 splits. And what we did is we had one tramline where we applied it at a flat rate, and then we had a variable rate comparison where we varied the second nitrogen rate. So the second nitrogen rate of 100 kilograms per hectare, we varied it of plus or minus 40 kilograms per hectare, so between 60 and 140. And we looked at yield from the 2 tramlines, and we didn't see any yield difference or yield benefit, no yield difference between the 2 tramlines. So, if variation in crop across the field is driven by variation in soil nitrogen supply, then we may see a saving. But at this particular site, we couldn't see any benefit. Okay, so next I just want to quickly look at fertiliser application technology, and specifically fertiliser placement. Placement, I think, is most relevant for phosphate fertiliser. We know soil phosphorus moves very little in the soil compared to nitrogen. And this lack of mobility and low solubility can reduce the availability of phosphorus fertilisers. It's fixed the soil P compounds. And young plants are especially vulnerable, because they have poorly developed root systems. And so I think there is a logic to placing phosphate fertiliser close to the plant. I've got some data here from the Targeted P project, which we had in the UK a few years ago. This looked at placing phosphorus in cereals, also rape and potatoes. The project did provide evidence that placing can increase potato yield compared to conventional broadcast application. Here we had three potato sites where we looked at placement. You've got the yield from the broadcast and the placed. You probably picked up the first one that jumps out there. We did see a decrease in the first year, but I would kind of like, not really look too much about there, because we didn't get the placement technology right that year, and we ended up having to place by hand. We got it right in the final 2 sites there, where we had placement technology, and both of these sites we saw a statistically significant increase in yield from phosphorus placement. So I would say that if you are particularly for veg crops that are in rows with limited rooting earlier on in the season, if you're a low P index soil, placing phosphate, you may well see a benefit from that. So I'd also mentioned matching nutrients, in particular nitrogen applications, to crop demand as a strategy to increase your nitrogen use efficiency. I think this makes logical sense. We want to apply our nitrogen when our crop needs it. I do think it's advisable to avoid high N rates at planting. This is mainly because of the potential risk of leaching losses. If you happen to get a very wet period following application, if your crop isn't very well established, then there is a risk that heavy rain may leach nitrogen below the rooting depth. We wouldn't tend to expect to see nitrogen leaching during the growing season, but these extreme weather events are becoming more common, and if you did get the very heavy rain, it's actually going to be quite difficult to estimate how much nitrogen you may have leached below the rooting depth. Now, I mentioned earlier about slow or controlled release fertilisers. These products aim to slow the release of nitrogen over a period of time, and this may help match nitrogen availability to crop uptake. And some manufacturers of these products are now saying that you can reduce the number of N splits compared to conventional practice. And obviously, if you can cut the number of splits, there's a saving there for you. However, I would say that there's limited evidence for yield benefit from these products at the moment. The other thing I've just noted there is, recently we have done some work in cereals crop with CF fertiliser, testing this hypothesis of little and often fertiliser applications increasing yield. So one of my colleagues, Kate Storer, she set up some trials comparing a 3-split nitrogen application to a 6-split nitrogen application. Again, logic's there. We might expect to see a yield increase, but actually she hasn't, she hasn't managed to see consistent yield increases at those sites. Finally, I am conscious of time, I'm almost there. I just wanted to highlight the value of on-farm tests, which I mentioned at the beginning. If you want to check whether your fertiliser rates are about right, you do think about setting up simple tramline trials on your farm. Apply a bit more and a bit less and see what impact that has on the crop. This sort of on-farm testing is now becoming more common in combinable crops. A few years ago, my colleagues at AHDE worked with AHDE on the LEARN project, which demonstrated the value of on-farm comparisons in cereal crops. Here, we were getting the host farms to set up simple tests of plus or minus 60 kilograms per hectare from the farm standard. They then used yield maps to assess the impact of different N rates. The challenge for us with horticultural crops is we don't tend to have yield maps, and so it's a bit trickier to measure the impact of yields. However, I don't think that should stop us. You've got a couple of options. At a basic level, you can visually assess. Ideally, consider if you're doing strip trials, can you weigh the amount of crop that you have off different strips? Or another option for you is using canopy sensing, from a drone or a tractor-mounted sensor as a proxy for yield to assess treatment differences. And that's something that we've recently demonstrated, this approach as part of the InnovEdge project I mentioned that we've been working on. So here we were looking specifically whether we could use canopy sensing as a proxy for yield to take measurements in experiments, and this approach has worked quite well. We have shown that crop canopy information can be correlated to yield, and we have used this in sort of field scale experiments. And I've just sort of put up there a case study there where a couple of years ago we set up an N rate comparison on onions, where the host farm compared the standard N rate with a lower N rate. It was set up with farm machinery. We used headland control to reduce the N rate, going up the tram lines on the lower N rate plots, and then we used drone imagery to look at the impact of those treatments, and that worked very successfully there. If this is something you're interested in, the project website which I've put there, we've recently just published this protocol giving guidance on how to use crop sensing data to assess crops and as part of experiments. So finally, to sum up, the recent hike in fertiliser prices has focused our attention on what we can do to maximise our nutrient use efficiency. This is positive for yields, farm profitability and the environment. I've said it again, it's worth saying it again, start by getting the basics right. Maintain your soil at target pH, ensure a good supply of phosphate, potash, magnesium, sulphur. Maintain good soil structure. If you are using organic materials, they're a valuable resource. Make sure you take account of the nutrient content and take steps to minimise your nitrogen losses. Assess your soil nitrogen supply and consider whether measuring from fields where SMN levels are likely to be high or uncertain. We have spent a bit of time talking about a number of other precision nutrition strategies, which I think all offer the potential to improve nutrient use efficiency. But I have also noted that the evidence base for some of these at the moment is a bit more limited. So, and finally, I know probably would say this because I'm a researcher and we like trying things out, but really do consider, if you're unsure about whether your fertiliser rates are right on your farm, you do consider the value of on-farm testing to check your fertiliser management decisions. And that's me finished.